So today we're going to be on page 143, and we're going to be talking about chord angles. So the objective for today is to use properties of chord angles. So first, let's recall what a chord is. So a chord is a segment whose endpoints are on a circle. So if we had a circle here with center O, then we can have a chord like that. That would be chord AB. So AB would be a chord. So we see that the endpoints are on the circle here. So we're going to be looking at angles formed by intersecting chords. So if we want to draw two intersecting chords, we have our circle. So we have chord C, D, and chord A, B. So we have when two chords intersect inside a circle, four angles are formed. So we have this angle would be 1, 2, 3, and 4. So now, at the point of intersection of our two chords, so point of intersection, we have two sets of congruent vertical angles are formed. So this would mean that angle CEB and AED are vertical angles, so these two would be congruent. And the same thing for CEA and BED. Those are both vertical angles, so they would be congruent. So the rule for intersecting chords, so the angle formed by two chords is equal to the sum of the intercepted arcs divided by 2. So from the picture above, we would have measure of angle AED is equal to the measure of arc AD, this is one intercepted arc, plus the measure of CB, which is the other intercepted arc from the two chords. And we have divided by 2. So to use this rule, we're going to look at an example. So example 1. So we're given AB, chord AB, and chord CD, and the measure of arc AC is 54 degrees, and the measure of DB is 32 degrees. So let's draw a picture to represent that. So we have our chord AB and chord CD. So arc AC here is 54 degrees, in arc DB is 32 degrees. So the question is to find the measure of arc AEC and also the measure of angle CEB. So we want to find both of these angles. So in order to do that, we want to use the rule that we stated above. So to find the measure of AEC, so that's the point of intersection will be E. So AEC, so we want to find out what this angle is first. So we're going to take the two intercepted arcs and then dividing it by 2. So we take 54 plus 32 divided by 2. And we're going to get the measure of angle AEC is 43 degrees. So if measure of AEC is 43 degrees, then that also means that the measure of DEB is 43, and that's because they are vertical angles. So we can say, so measure of angle DEB is also 43 degrees. So now we need to find the measure of angle CEB. So CEB is this angle here. And we see that the angle that AEC that we just found is 43, and angle CEB make a straight line, so we know that's going to be 180 degrees. So we're taking 180 minus 43, and we get the measure of CEB is 137 degrees. So if measure of CEB is 137 degrees, this angle, then angle AED would also be 137 because those are vertical angles. So the next thing that we're going to look at is parallel chords. So if you want to see a picture, so if we have chord here, A, B, then a parallel chord, so a chord parallel to that one would be CD. So we see that these two are parallel. So AB is parallel to CD. So our theorem is that in a circle, parallel chords intercept congruent arcs. So that would mean that arc AB is going to be congruent to arc CD. It would be arc AC, AC and arc BD. So AC and BD would be congruent. So if you look at an example, so we have a circle with chord C, D, and chord A, B. So we have chord CD is parallel to the diameter, which is AB, and we're given that measure of AC is 40 degrees. So we want to find what is the measure of arc CD. So we have that this arc here was 40 degrees. So since in our theorem we say in a circle parallel chords intercept congruent arcs, then AC would be congruent to BD. So AC is congruent, chord AC is congruent to chord D. DB, so we have, they're both 40 degrees. So we want to find the measure of arc CD. So we see here that since we have our diameter at AB, this makes a semicircle, and the semicircle measures 180 degrees. So since AC and BD are both 40, then we just need to subtract those from 180. So we can write, since AB is the diameter, then we have arc AC plus arc CD plus arc DB is equal to 180. So we have 40 plus x plus 40 equals 180. And then we're left with 80 plus x equals 180. Subtract that 80, and we get x is equal to 100. So measure of arc CD is 100 degrees. So we have to remember that these intercepted arcs of our parallel chords are congruent to each other.